Welcome and thank you for joining us in the second day of MESA Week. Today's theme is engineering and we are happy to have you here. We're in Career Insights hosted by Portland Workforce Alliance. My name is Robin, so I'm going to be your MESA host for the whole entire day and I'll be introducing every single session. Be sure to submit your questions in the right-hand side of the Q&A and upvote your favorites. We're going to try and get as many questions answered as possible. Few housekeeping items. This session is being recorded, but audience video and audience audio are off. Make sure to send questions through the Q&A tab on the right-hand side of your screen, and we'll be making sure to remove people who are posting inappropriate content. Students, stick around at the end and be sure to answer our survey so that you can be entered for a Games and Gadgets Electronics Lab. And with that, I'll hand it off to Julia.
Awesome. Thank you, Robin, and thank you, MESA, for having us here today to have this panel. I'm really excited for all of our folks that are joining us on this webinar. As Robin mentioned, my name is Julia Soto. I work for a nonprofit called Portland Workforce Alliance, or PWA. And we are the folks working behind the scenes with your schools and your educators to partner with local businesses and industries to bring you all students career opportunities like this one today. So today I'm excited to be joined by Alex Berry, Courtney Wright, and Ashleigh Lyon, all here to share their insights into engineering careers. So we've got a nice packed panel, so let's get started. We're going to jump right in with Alex. And Alex, you are a technical program manager at Intel. I'm really excited for you to tell us more about yourself and what your engineering role at Intel looks like.
Yeah, thank you so much for that, Julia, and hopefully everyone can hear me. But like she mentioned, I am a technical program manager at Intel, which is just a really fancy way to say that I play lots of different types of technical project management and other different types of cultural games at Intel. I'm able to get lots of folks together to play those games with me, and when we're successful, we're able to make and save a lot of money. Originally, I'm from Southwest Georgia, and I actually grew up in a kind of a smaller, more rural area. And now I'm really excited to be over here in the Portland, Oregon area after having traveled the world in my youth. My academic background is that of an industrial and systems engineer, which is just a fancy way to say a math major plus a business major plus a computer science major plus a couple of Chinese classes plus a little bit of financial engineering. And you take all of that and you put it in a smoothie, and the resulting liquid you get is that of an industrial and systems engineer. On top of that, when I think about what I do for my day job, it really breaks down into three main things. So first, I do a lot of process improvement, which is basically where I get to use a lot of cool data and math to help eliminate waste from Intel's manufacturing and supply chain process. Second, I do a lot of project management, which is me going and helping to manage money, to manage time, and especially to manage risk. As when you have big, large organizations, you don't want to have too much risk. And then finally, I do a lot of facilitation, which is just a fancy way to say I get paid to go and to make games and workshops about really complicated technical topics. And I go and produce those workshops for Intel as well for a lot of external audiences. So super happy to talk with you guys. I'm going to go and turn it over to our next speaker.
Awesome. Thank you, Alex. I think we had a real quick question too. How long have you worked at Intel?
Oh, yes. So I've worked at Intel for a little under 3 years. It's been a really exciting time there, and I'm actually on my 6th job in 3 years. So I've kind of worked a little bit of everywhere.
Wow, that's a lot. Yeah, Intel's a big company, and there's a lot of opportunities, I'm sure, there. You can tell us more about, hopefully, in the Q&A. Moving on to Ashleigh, our next panelist. Ashleigh, you are an engineer as well, working at Nike. And I know we've already started to get a few questions about you and your background. So why don't you share more about what you do there?
Great. Yeah, so hi, everybody. Thank you for having me. So I am Ashleigh Lyon. I grew up here in Tigard, Oregon, where I went to Oregon State University, where I studied manufacturing engineering and minored in business. And I also studied abroad, spent some time in Denmark studying engineering there as well. So I highly recommend that if anybody has the opportunity. And just really quickly, my career journey, I started as an engineering tech at Cascade Tech doing environmental testing. And then I moved to Tektronix as a product engineer. And then now recently, for the past 4.5 years, I've been a Flyknit engineer working at Nike, specifically with sportswear product. So Air Force One, Vapormax, if you think those shoes. So what is Flyknit engineering? Just to give a quick overview. So basically, we work in development with a designer. And on the very left on the slide, you can see that was an original CAD drawing or initial design from a designer. And then so I go back with my team where we work on these Flyknit machines that take up to 26 cones of yarn to produce these uppers here that you can kind of see in the middle. So on the left side, you see the very first upper we made. And on the right is the final upper. And sometimes this can take up to 100 revisions. And so my job as the engineer, we're making the jigs, we're defining the post processes, the things that go into making that final shoe that we're going to manufacture at the end. Because I think the one thing you need to realize is you can make one sample of anything, but I think a big challenge at Nike is we're so large, you need to always be thinking about manufacturability and, being able to make thousands, if not millions of pairs of shoes. So we kind of facilitate that process. And then lastly, I did want to touch on a project I was able to be a part of for the month of April, was kind of switching our gears from footwear over to PPE. And our Flyknit team was able to develop a program in about a half a day to produce these face coverings that I'm sure people have heard about due to the coronavirus, that they're helpful as well. So we were able to make about 80,000 of these at WHQ here on campus with a small team of volunteers. And then we're able to transfer all the information over to Asia, where they produced 160,000 masks in about 2 days. So you can see how big their workforce is. And then these face coverings were to be provided to all of our Nike employees right now that are still working. So mainly in our distribution centers who are making Nike.com still function, as well as our RMI folks who are also working on PPE. So that's been really great to be a part of. And that's all I got.
That's great. Thank you, Ashleigh. Thanks for sharing that background. I hope folks have some more questions. I just want to give a brief reminder that we do have one more panelist to introduce, and then we'll move on to some more Q&A. So if you guys have questions, go ahead and put those into the Q&A section, and any questions you can think of, I think are fair game. Obviously, we'll be moderating those, and you can upvote any questions that you already see there. So to move on, we have one more panelist. We have another Nike engineer. Nike is killing it with engineers. And I'm excited for Courtney Wright to be here as well. So Courtney, tell us a little bit more about what you do at Nike.
Hey everyone, my name's Courtney and I work in the same building as Ashleigh at Nike, but I work more on the bottom outsole, midsole side of things, innovating the way we make shoes, to make the midsoles, the cushioning part of the shoe underfoot more sustainable, also working to deliver new performance benefits to athletes, and then always cut costs wherever possible to make our innovation scalable. A bit about me, I grew up in Northern California, and then I went to the University of Michigan to study mechanical engineering. I didn't know I wanted to study mechanical engineering at the time. I was looking into aerospace and a couple other things. So it's good to keep an open mind when you're going into school. And then now I work at Nike. Throughout college, I had a bunch of different jobs. I had a work-study job tracking comets through our space research program at Michigan. And then the job I had before interning at Nike was interning in Ohio as a toilet paper engineer, which was fun. I learned a lot. It's crazy actually how many similarities there are between toilet paper engineering and footwear engineering. So it's great to keep an open mind, that you can really learn, get experience from anywhere, and apply that to your dream job. I did pick up a couple shifts helping Ashleigh's team with the Flyknit masks, but they really did all the work pulling. Ashleigh was working every day of the week, so great job to her team. Most of the face shield work that you may have seen in the news was done by RMI, but I did help out with a mechanical drawing to send that over to Asia. I also just wanted to include this picture. It's a great example of what I do on a day-to-day basis. Two of the main ways we prototype things on my team are 3D printers and machines. So drawings are the way that we get our ideas across to our manufacturing teams. This is an example of kind of a fun project I worked on earlier this year, designing a trophy for an event at Nike. I think the slide got a bit mixed up, but it's a good example of the process that we go through, starting out with concepts and pictures, then working in CAD software like SolidWorks or Rhino to create the model from drawings, and then finally fabricating and assembling the project with 3D printers or machinery. This is the process my team goes through when we solve problems. And then a little fun fact, the first Nike shoe was made in a waffle iron in the founder's wife's kitchen. He ruined her waffle maker, but this is what we innovate today and what we seek to improve from the original waffle iron.
Awesome. I'm going to scroll back so everyone can see that cool waffle shoe one more time. Thank you for sharing that, Courtney. We are getting some great questions. And I think since we just heard from the Nike folks, one of the questions that has come up that I think would be great to have you guys is talk about how long does it take to make just one shoe?
Yeah, so I mean, so in our building as well, where Courtney and I work, it's called the Advanced Product Creation Center. We actually have a small manufacturing facility within the building where we can build a shoe in probably an hour, I would say, as long as we have that bottom unit, that tooling that Courtney was talking about, the foam, as long as that's ready to go, because that's a separate process.
And when you're, some of the other questions, kind of just sticking on the shoe question for a little bit, or at least the side of Nike, is a little bit wondering too, as both of you have talked about the PPE, one of the questions that has come up is switching, how did Nike make that switch so quickly to, from making shoes to PPE? What was that like? Is that something that you guys have done before in the past? I think we're really curious to hear about how companies can be adaptable at times like now.
Yeah, I can answer for the Flyknit side, because myself and another engineer, we kind of got pulled in because I think the initial thought was, can we produce something for medical in Flyknit that would help the shortages that we all heard about at the beginning? And so that kind of switched gears once we heard the CDC come out and say a face covering is good because it helps you protect others from yourself. So it prevents you from touching your nose and your mouth. So as long as you're making a fabric covering, that'll be beneficial. So we said, okay, let's design this quickly. And we rearranged our workspace, which probably have 45 of those knitting machines I showed in place. And then we had a post-processing area that we kind of changed to a single cell flow and just kind of trialed and error. And as we started getting more volunteers in, we just got faster and faster and faster every day. But the face masks are a lot simpler than shoes. So we were able to produce a lot pretty quickly. I think we averaged about 5,000 a day versus if you think what we're probably sending for footwear, we're probably only sending about 50 shoe uppers out a day in Flyknit. So to be able to send 5,000 of these masks out a day was pretty significant.
On the face shield side of things, again, I definitely was not leading the charge on that. There's a lot of really helpful information out there by some awesome publications like Fast Company if you're interested in learning more. But one thing that really struck me as I was involved in a couple of the initial concepting meetings is how the frontline workers in the medical industry were used as the athlete, and it was set up just as we would a brief for any other project with the end user in mind from the very beginning. And so there were interviews conducted with doctors and nurses and other medical staff to make sure that we were designing something that was actually needed, that we weren't just creating things that would sit on a shelf and not be helpful. And then we did repurpose for that the materials that are used in our airbags at our manufacturing site in Beaverton.
That's really interesting to hear. And also too, as someone who doesn't know Nike as internal operations as well, we know you're a big organization, but it was just only in the last few years I heard about the massive scale of manufacturing that you have here locally. So I think that's helpful for folks to know that it's an opportunity that is available here in Oregon, and you have facilities that are producing manufacturing items and need engineers like yourself. So that's really helpful context. I want to switch gears a little bit because we've been getting some great questions that I think Alex can weigh in as well, and thinking a little bit about how you get into an engineering career. So let's start with Alex. Definitely a few people are interested to know what classes do you recommend students start taking in middle and high school, and real specifically, what levels of math and science would you say to have finished by the end of high school? So real specific details about your high school life. And I'd also like to hear from Courtney and Ashleigh on their take about science and math classes too.
Yeah. So I'm happy to go and kick that off. So first, I would probably say that my high school portfolio, my high school background is not necessarily what you would expect of a typical engineer. I was actually failing calculus at one point in my high school career. My best subjects were actually English, literature, and history. And I might argue that I kind of tripped over into industrial engineering and have loved it ever since. So for me, the most important maths you're going to take outside of your basic maths of algebra, geometry, and trigonometry, oftentimes the next level in most schools is calculus. If you're in an AP system, calculus AB or calculus BC. But something that people sometimes struggle with is that calculus never feels immediately useful. So something that I wish I had done in high school was actually take statistics, because statistics is something, or statistics and probability is something that you can be using immediately, whether you want to figure out how to understand different trends, whether you want to go into find maybe just some more useful applications if you want to start a small business, from a lemonade stand to help better run one of your student clubs. So again, statistics would have been one I would have highly recommended. When it comes to the science side, definitely your basic sciences are chemistry, biology, and physics. Most engineers have a really, really core emphasis on physics. But one thing that's more interesting with industrial engineering, which is what I practice, is that for us, computer science is actually more important than physics. A lot of our math is based off of a special type of linear math, where computer science can kind of directly translate our math into different process improvements and different systems. So again, the most underrated classes I think would be your intro computer science classes, as well as your statistics classes. But I'd love to hear from Ashleigh and Courtney if they have a different opinion.
Yeah, Courtney or Ashleigh, would either of you want to weigh in on that?
Yeah, I totally echo everything that Alex was saying about classes he was recommending. Another thing as a mechanical engineer that I found really interesting was finding any opportunity possible to work on a side project, to find a way to start building things yourself and applying concepts you were learning. One of my favorite projects in high school that got me so excited to study engineering was I ordered a small Arduino board and some wires online and was able to connect them to my computer and some bananas to make a piano, and watch them. My high school didn't have a computer science class, but there are so many great online resources these days, or just sample codes that you can start plugging in to your programs, and so many tutorials and sample projects on Arduino.com and things of that nature, to just start using your hands to build projects outside of the theoretical classes.
Awesome. Yeah, the only thing I would think to add to that was, I mean, depending what engineering you're interested in, like if you want to work with product, one thing I really enjoyed that I have found very useful in my job now is material science, and like understanding the different properties of materials and their strengths, hardnesses, stiffnesses, how they react together, has for sure been really helpful and very interesting.
Yeah, I'll put a vote in for material science as well. It's a great study, and I think what we're also interested in hearing from you guys from the audience is talking about how you came to choose your engineering careers. And I'll just layer my little editorial on that. Is engineering is becoming so interdisciplinary as well. And I think you touched on that with the types of classes that students can look at. So hearing a little bit more, maybe staying with you for a minute, Ashleigh, what led you to choose the type of engineering? What got you into it? How did you get excited? And then we can jump over to Alex and Courtney as well.
Yeah. So I really wanted to do graphic design. I was always a very creative person. And I think what kind of steered me into engineering was for sure my parents. They said, engineering can also be very creative. There's a lot of creative problem solving, and it will open the doors to so many different types of jobs. Like you said, there's just endless possibilities, multiple companies, multiple industries. So definitely have my parents to thank for that. But I started in civil engineering at Oregon State, but then I realized, maybe the roads and the bridges constructions aren't for me. And so I actually took an exploratory class that, which hopefully a lot of colleges are offering now, where they do, 2 or 3 week sessions worth of each engineering type, and then you can kind of steer yourself from there. So that's when I discovered manufacturing engineering and lean process improvement, or like kind of black belts, if anybody's heard that term, just optimization and efficiency and just improving processes. And I really gravitated towards that. So that's why I chose manufacturing.
And jump in there, Alex. It looks like you unmuted.
Oh, yes. So I think for me, it was definitely, again, an interesting journey. So again, going back to high school, I was the person who liked reading Shakespeare, and I was very, very much more so into history. And so the way I describe my sort of jump over into industrial engineering, it's a major that deals a lot with data. And what we always go and tell folks is that when you can understand data, you're really able to understand what has happened. You're able to understand sort of the history of different systems, or the history of different mathematical problems. And then even better than that, you're able to use that history to do lots of different kinds of forecasting, and to, in some cases, be able to predict the future. So that was always really interesting for me. And then from a literature side, I always love to be able to not just understand problems mathematically, but to be able to contextualize them, to understand how to go beyond the numbers. And so for me, industrial engineering was a great way to do that, but not just, I guess, understanding different systems or different maybe socioeconomic problems like homelessness, but being able to actually go and use that math and science to make recommendations that will help people make better decisions. So for me, it was all about how do we go and help really smart people and really passionate people make better decisions that we can actually back up with some math and science.
Yeah, it's interesting. I've never heard anyone put it in those terms before, but thinking about data as a form of history. I really appreciate that. Courtney, what about for you? What was it that attracted you to engineering? How did you get into your field?
Yeah, I was always interested in the creative making side of things. Growing up, I always wanted to be an architect. Similar to Ashleigh, I had some great role models. My grandfather was an engineer. My parents weren't engineers, but they also convinced me that engineering is just a field in college that can open so many doors, even if you don't want to be an engineer for the rest of your life. So I decided to apply to Michigan's aerospace engineering program and take some aerospace classes my freshman year. Was really excited about a hands-on project I was involved in, building a blimp, and just loved the connection of all these different systems, the hardware, the software, the structural side of things, but realized that aerospace was a very specialized field. In undergrad, I didn't want to get that specialized. So switched over to mechanical engineering because I was already on the track working towards that degree, and just fell in love with the way that all these theoretical concepts that you learn in calculus and physics can be used to solve real world problems related to renewable energy, biomedical design, and just making any type of manufacturing process more sustainable.
That's great. Thank you. We've got like a few minutes left for a couple more questions. There was a popular question that was asked for some of the Nike folks about understanding a little bit about environmental sustainability integrated into your work. I wonder if someone would want to take that up in like a minute or less, so we can maybe have time for a couple other questions.
Yeah. I know they're looking, I don't know if they've published too much about the way we're looking at sustainability right now, but the way that we've been looking at it for the past, I've worked at Nike for 2 years. So for the past 2 years, it's been explained to me that there are a lot of factors that affect sustainability, but at least for the bottom cushioning side of things, energy and carbon impact are the most important factors in that. So we're looking at the ways that our manufacturing, there's so many uses of energy in terms of transportation of materials, the way materials are made from the source. So we're working to source more sustainable materials, but then what we can control directly on my team is how we manufacture things and how we can use less energy and less carbon to create our footwear.
Awesome. Thanks, Courtney.
Yeah.
I'm going to jump over to Ashleigh for a second because we got a question. How could you quickly describe the difference between a mechanical engineer and a manufacturing engineer?
Yeah, I would say a mechanical engineer is more focused on the actual design of, whether it's a physical part or a fixture or a piece, that's going into an end product, versus a manufacturing engineer. They're thinking about the entire process to get from the initial design to a finished product and all of the different processes that go into that and how you can lower cost, you can increase your yield, reduce your defects, like all the different factors to get the best product for the lowest amount of cost.
People also jump around to these roles all the time. I'm a mechanical engineer, but I work on an engineering and manufacturing team. So a lot of it is just names and titles and semantics.
Yeah, I noticed that with
explanation. I agree.
I was going to comment too and bounce back to Alex. We have another question too related to what your companies are looking for in terms of candidates, but I want to segue into that too, just by referencing that someone with an industrial engineering background can come to be a technical program manager at Intel. So I think that goes to say that engineering as a whole, regardless of what specific discipline you study, is still a very valuable, very well sought after. So I guess, Alex, thinking more specifically about that question, what do you think folks at Intel are looking for from students that are applying for positions?
I would definitely say it comes down to three things. First, we definitely hire a lot of folks who are extremely technically savvy and have a lot of project work to back that up. And that doesn't necessarily mean it has to be formal internships or you have to have a technical degree. Many of the folks I work with on a day-to-day basis don't even necessarily have a college degree, which I always thought was a really cool thing about Intel. But you got to be technically savvy and you have to really know your stuff. Second, you got to be a good team player. It's not just about what you're trying to do or what you're trying to build alone, but it's how you're working with a lot of other really smart, passionate people to deliver product at low cost. And then third, and I think this is more of a rising thing, at least within Intel, but we were, especially during the pandemic times, we are really looking for folks who are a little bit more compassionate and actually care not just about their work, but also about their teammates.
Those are fantastic. I can imagine at Nike too, you guys are looking for similar qualities in like about 30 seconds. Would you add anything to that from Nike's point of view, what you guys are looking for?
I would just emphasize that we're looking for people that, work really well with others. We work in such collaborative, open environments that if you can communicate well, so communication for sure, well with others, that's key.
I totally echo. Sports can't hurt as well.
Yeah, a lot of people do have a sports background, but you don't need one.
Yeah, especially on my team within innovation, curiosity seems to be a huge fact as well. You can be working on your own projects at home, but also just being well-versed in industry technology out there, looking at publications of cool things going on in terms of like 3D printing homes, because that all carries over to everything across all these industries. So just draw inspiration from everywhere.
Fantastic. And I think that's a good maybe note to end it on and pass it back over to Robin. I think curiosity is a good place to be right now. So thank you all for your time. And Robin, I'm going to get it back to you to wrap us up.
Thank you.
Yeah, thank you so much. What a great panel. I really appreciate Julia for moderating, and thank you so much to the speakers, Alex, Ashleigh, and Courtney, for giving us insight into what you do and the interesting paths you took to get there. The the link to our survey just popped up, so students make sure to fill that out. You'll get an entry into our raffle for our Smart Circuits, Games, and Gadgets Electronics Lab. And we're going to announce the winners at the end of the session on Thursday during our MESA end of the week celebration. We'll begin our college session hanging out at 1:45. See you then.